The daily dosage of 2000 IU, international units, of vitamin D3 has become a focal point in both clinical research and practical health guidance, particularly for its potential role in slowing biological aging and supporting systemic health. This dosage reflects a middle ground between the conservative recommendations intended to prevent outright deficiency and the higher doses often used in therapeutic settings. What makes 2000 IU especially relevant is its balance of efficacy and safety, offering a consistently effective amount to raise serum vitamin D levels into an optimal range without introducing the risks associated with excessive intake. Clinically, the choice of 2000 IU is based on its ability to bring blood levels of 25-hydroxyvitamin D, the circulating form used to assess vitamin D status, into the range of 30 to 50 nanograms per milliliter for most adults. This range is widely considered ideal not only for bone health, but also for immune function, inflammation control, and cellular protection. Research has shown that once this threshold is reached, vitamin D begins to influence broader physiological markers, including those associated with aging. In particular, higher serum levels are linked to longer telomeres, lower inflammatory cytokine levels, and reduced markers of oxidative stress, three pillars of aging biology. Telomere length, a well-studied biomarker of cellular aging, appears to benefit from vitamin D status in a dose-dependent manner. Several population studies and clinical trials suggest that individuals with higher 25-OH D levels tend to have longer telomeres, especially in leukocytes, where cellular turnover is high and oxidative stress accumulates rapidly. While causation is still being explored, the association is consistent enough to suggest that maintaining adequate vitamin D may help preserve cellular youth and delay senescence. Supplementing with 2000 IU daily has proven sufficient in many studies to elevate low baseline levels to this telomere protective zone, making it a pragmatic intervention in aging research and preventive medicine. Beyond telomeres, vitamin D at this dose exerts measurable effects on other aging-related systems. For instance, inflammation, often considered a root driver of biological aging, is directly modulated by vitamin D. A 2000 IU daily regimen has been shown to reduce levels of pro-inflammatory markers such as interleukin-6, IL-6, and C-reactive protein, CRP, both of which are linked to increased risk of chronic disease and accelerated aging. These changes are not merely cosmetic or statistical. Lower inflammation is associated with reduced risk of cardiovascular disease, cognitive decline, and frailty, all key targets in the effort to extend health span. Another notable advantage of the 2000 IU dose is its impact on immune regulation. Vitamin D plays a critical role in the function of both innate and adaptive immune responses. Aging is often accompanied by a gradual decline in immune performance, a phenomenon known as immunosenescence. By supporting immune cell differentiation and reducing inappropriate inflammatory activation, vitamin D helps counteract this decline. Clinical trials involving older adults have demonstrated that daily doses of 2000 IU improve immune resilience, reduce the risk of respiratory infections, and may even help modulate autoimmune responses, which are known to become more common with age. Importantly, the safety profile of 2000 IU per day is well established. This dose is far below the upper intake level of 4000 IU/day defined by most health authorities, and long-term studies have shown no consistent adverse effects when taken under medical guidance. For most people, it is sufficient to correct suboptimal levels without requiring blood monitoring, making it a convenient choice for widespread supplementation. That said, individual variability in vitamin D absorption and metabolism, due to factors such as body weight, age, genetics, sun exposure, and dietary habits, may still necessitate personalized adjustments. In sum, the 2000 IU daily dosage of vitamin D3 is not an arbitrary number, but a clinically validated amount that bridges the gap between deficiency prevention and optimal physiological function. It is high enough to support telomere preservation, reduce systemic inflammation, enhance immune balance, and improve multiple aging-related biomarkers, yet low enough to avoid toxicity or overcorrection. As a result, this dose has emerged as a foundational element in evidence-based approaches to slowing biological aging and maintaining long-term vitality.